Morning, everybody. It's not quite 9:30 yet, and being the first session of the day, it's a little bit slow start. My name is Donald Jolly. I'm one of the ZANOG Organising Committee members, and welcome to day 3 of ZANOG at iWeek. I'm also I make a little bit of noise so that people can hear what's going on outside, and then they tend to filter in. Just who was here for my ZANOG newcomer session on Tuesday morning? Nobody, so one person was in the plenary. So did everybody arrive late or just here for the day? Okay, good. So who's attending a ZANOG for the first time? Okay. Or a NOG, maybe I should say that. I think you've probably been to a few, but from a conference perspective and an event perspective, it's great to see some new people. It's typically, when we run a ZANOG conference, we try to keep a single track, because you often sit there during the day and you go, okay, well, which one should I go to? Fortunately, in this case, we are recording them, so if you do feel that you're missing out on the other side there, you can go watch the recording later. All right. This is Radok Zimba from Poland. Welcome to South Africa. Are you just going to be presenting, or will you? Okay. All right, great. As I said to Radok, I'm not going to introduce people because they know far more about themselves than what I know about them, and so I will leave that up to them. So thank you very much.
Hello. Again, let me introduce myself. My name is Radek Zimba. I'm from Poland, and today I would like to share my experience in PON network. Especially what I would like to present is how to open the PON network and FTTH environment in order to have unbundled products that give you freedom of choice and control about your network. So let me just hop in with the first slide. I'm one of the co-founders of Halde Networks. This is the products that we actually create in order to open up the PON environment. As we started in 2009, we seen that there was only a choice was to buy everything from a single vendor. But if you buy everything from a single vendor, then you actually get married with that vendor. It's very hard to argue, it's very hard to unbundle. There was a situation on the market that some of the vendors disappeared, they killed the products, and that was creating some mess for the deployments. So in order to tell you more about the interoperability, let's see how the standard looks like. So if you have OLT, which is central office equipment, that need to talk to the ONT, which is modem at subscriber house, the standard define OMCI, which is ONT Management and Control Interface. This is the standard that is quite old. It was focused on L2 features like configuring VLANs, and it doesn't go beyond L3. At least that was not the intention of the people that was creating the standard. There was a couple of challenges related to the OMCI, and finally it has been superseded by the separate standards in order to have similar, interface between GPON and HGS PON. That's why we are talking about this G988 OMCI. Of course, this is not only something which is mandatory for the vendors. The standards give the option for the OLT vendors to select which standard revision they're gonna use to set up configuration between OLT and ONT. Unluckily, as like in the telecommunication standard, there is some exceptions in the standard that allow vendor to use their own configuration messages. And first of all, when we talk about OMCI, there is no single standard. There are a couple of revisions of that standards. So as you can see, there was one in 2010, then there's another one in 2017. And there's also a few messages that can be used by the OLT vendors for whatever they want. Yeah, so they can actually use it for configuring L3 features. They can use it for Wi-Fi. They can do whatever they want with that message, and they don't need to disclose information what those messages are actually carrying. Yeah. So in order to give you some sort of example, what is OMCI? The best comparison, in my opinion, is actually to compare it to SNMP. So with SNMP, we have a certain protocol, but different vendors have their own MIB files, which gives them, let's say, some sort of freedom how they set up the configuration between OLT and ONT. Similar, I think it's also TR069 that allow vendor extension. So it is not like you buy some ACS and all of the products that support TR069 gonna work fine with that ACS. So how that OMCI looks in practice. So let's look on the most popular products on the market, like Huawei. You see there are certain class ID which are open, which are standardized, but there are also a lot of unstandardized reserved management entities, which means that it is kind of difficult to make full interoperability with our products. Similar with Nokia, and there are certain vendors like Ubiquiti that does not use any public management entity or very limited. Yeah? This actually means that you buy their products and you can only use the products which they allow in their software to be configured. So for example, it is quite, I will just underline this Ubiquiti because I know it's kind of a popular OLT vendor, but as you can see, they only use private management entities, which means that it is highly difficult to unbundle from that vendor. This is also kind of an example when you can sell cheap OLTs. So everyone is attracted with the cheap price of the products, but later on you get money back on the OLTs. So this is not exactly something that in telecommunication we would like to see. So what sort of approach we have to get rid of this vendor locking and how to open the PON network? There are plenty of OLT manufacturers in the world. Yeah? So wherever we sell our products around the world, we see in different regions, they have different OLT vendors which are more popular than the others. What is more, some of the OLT vendors, they have different software depending on the region. So as you can see, there's like currently we identify above 27 OLT vendors. Some of them are from Asia, some of them are from US, some of them are from other countries. Yeah? So at the very beginning, some OLT vendors were selling their OLTs cheap, but they were not exactly clear that you can connect third-party entities. Wherever you would talk with some salespeople, they say, no, this is basically too difficult. It's like rocket science. They were trying to scare you off that you're not going to get support, you're not going to get proper provisioning of the products. Once the third-party entities came to the market, some of the vendors introduced licensing, which is pretty, I will say, nasty practice because some of the OLT or some of the customers were not aware about this licensing once they were purchasing the products. Okay? So there are some official and unofficial options to block third-party ONTs. For example, you can use only private management entities, you can use licensing, and some of the vendors also use another option, which is they sell you their NMS, which is mandatory for their OLT, and that NMS cannot provision third-party entities. So be aware of that. There are some options to unbundle, so we can tell you more about that in the next slides. But is this blocking is only mechanism of the OLTs? No. I will just give you an example that it was one of the first projects we joined in 2009. Unluckily, we lost with one of the vendor that offer bundle solution to one of the regional operator in Poland. But through the time, this vendor announced in 2015 that the OLTs that they were selling in 2009, they actually are going to be end of sales, end of life. So they need to replace the central office equipment. Yeah. And so they made RFI, RFP, and in this RFI they actually mentioned that new OLT vendor need to support existing ONTs which they have in their network. Yeah? But basically those ONTs were coming from that vendor, and anyone on the planet was actually, we cannot guarantee that we're gonna support third-party ONTs which is actually not ours. So frankly speaking, they can only select the vendor that they actually select from the bundle offer in 2009. So this is kind of also blocking mechanism. Wherever you buy ONTs, ensure that those ONTs gonna work with other vendors as well, because you never know what's gonna happen. We are living in the world where, let's say, US is fighting with China. We are in the middle, and basically supply chain can change. Yeah. So if you have ONTs which are very hard to be replaced, because those ONTs are in the house of subscribers, so ensure that those ONTs gonna talk at least with the two OLT vendors. Yeah. So they're gonna be supported. Yeah? So how to secure your interest? Yeah. First option is basically get a contract. Yeah. So once you buy the products, try to talk to your distributor or to the vendor, and ensure that a couple of points in the contract are there, which means that they do not have any official or unofficial blocking mechanism, that they can recommend you different ONT vendors, so that you can actually test all the products with different third-party ONT vendors. And this is applied for GPON and HGS-PON. And this is basically not going to be also any blocking mechanism in the NMS or EMS system that they're going to promote. Yeah. Okay, so what is the best? So what to do? First of all, what I will recommend is to start buying the products from the ONT vendor. So select first of all the make it tender for the ONTs. So you're gonna select which ONT vendor is actually cheap, which is fulfilling your requirements, and ask this ONT vendor for the OLT recommendation. Yeah. So what we do, we are actually cooperating with few OLT vendors. So we talk to them. We can recommend the one which are open without any official blocking mechanism. So this means that you are getting vendor agnostic ONTs, you are getting OLT vendor who support that ONTs, and you are getting OLT vendor which is open for others. Yeah? This means that you have unbundled. You have two companies, each of them are independent, and then you have unbundled offer. Yeah? Why this is actually important? Because you see, in the CapEx spendings, OLT value is actually getting very small. Yeah? Where are the money? Monies are in the ONTs. Yeah? So you're going to spend much more money in the ONTs. Yeah? You're going to spend much more money in replacing those ONTs, because going with engineer, dispatching engineer to subscriber house is a huge cost. Yeah? So once you're going to be trapped with the ONTs, you're stuck. Yeah? So how does interoperability looks like in reality? Wherever we do interoperability, because we started without any cooperation with the OLT vendor. Yeah? So what we do, we are actually sniffing the packets, ONCI packets that are being exchanged between OLTs and ONTs, and we actually try to replicate that with our own technology. What we invented adaptive OMCI stack, which is the software inside the ONTs that it has this kind of sensing technology. So we know to which OLT we are connected, and based on that, we are adapting ONCI communication with that OLT vendor. So this means that if you're gonna select our products, out of the box you have 12 OLT vendors, you don't need to change the software. The intelligence on the ONT is actually making that interoperability. Yeah? Some of our ONTs have this even Wireshark possibility to dump the traffic. So if you have the ONTs at your home, at your lab, what we can do, we can ask you like, okay, we don't need to dispatch an engineer with very, let's say, costly equipment. You just connect laptop with any desk, and we can actually sniff the packets. We can do interoperability in a matter of days. Yeah. So what are the advantages? Yeah. As I mentioned, the global situation is a bit uncertain. So certain operators have this kind of policy, which is minimum 2 OLT vendor policy. So usually it's like from Europe, it means that they have one, let's say European or US, and another one from Asia, just to have a healthy balance. But that's create a big chaos, how to handle with the ONT stock, how to train the engineers, which OLTs they're supposed to pick up, because they do not know exactly to which OLT they're going to be connected. So this is actually create some headache, and this is the gap that we actually try to fill. As I mentioned about this adaptive ONCI stack, you can actually go to YouTube and see how it works. It means that actually ONT is basically adapting the communication to the different OLT vendor. As you can see, there is a list. Before, when we started, we was actually checking the every OLT with different software. So we have like 12 OLT vendors in our lab, different software. So we are actually running the test. But to be honest, it doesn't make sense because the OLTs need to be backward compatible with the oldest ONTs that they do not support. So if we are actually behaving exactly like the oldest ONTs that they do not support anymore, this means that the interoperability gonna stay there. Yeah. So don't be afraid that some of the software release will change the ONT or will introduce some nasty vendor locking, because it is less likely that it's gonna happen. Yeah. So why this interoperability give you is something that is worth to try. First of all, that give you freedom of choice of the ONTs. We've seen that some of the OLT vendors, they do not have a broad portfolio of the ONTs. They are sometimes missing some of the ONTs that are, for example, targeting business customers. So you can actually get a new type of products that you can get ahead of your competition. You have better control of the capex and opex, and of course you eliminate vendor locking, so you actually get back control about your networks. And if you have, let's say, single ONT, then you reduce also the complexity. So it's better to have a single ONT which is integrated with ACS or with provisioning and with training of the engineers, than having a few different ONT models from different markets, different stock. So it actually simplify your operation. Yeah. So what else? We are talking about the OLT and ONT, but what is also crucial is to have, let's say, management system that's gonna be cooperating with minimum these two OLT vendors. Yeah. It is something that we also find out that in order to have control on the capex and opex, some of the, let's say, products, they introduce quite expensive OPEX cost on the management system. And that's why we actually see that it is kind of good to go ahead of that. And first of all, it's kind of good to have a full view what is happening inside the fiber network. So what we can do, you can actually we promote OpenILT, which is also our management system. This is kind of the system which we can actually combine monitoring of the fiber infrastructure. You can have zero-touch provisioning of the ONTs, and also you can have a view what is happening inside the subscriber house with monitoring of the Wi-Fi. Yeah? So this is actually the system that works with 5 OLT vendors now. So you can have a single management system for zero-touch provisioning, and OLT vendor is actually not relevant at this stage. Yeah? So that will be all from my side. I hope I didn't take much time, and I'm looking forward for your questions.
Thank you very much, Rad. I think what I liked about this presentation is the word open a lot of the time. I think a lot of us like the word open, especially something like an open bar, standards. So I think interestingly enough, from a ZA PC program committee, we don't like vendors to stand in front of people and tell them all about their product. But when they come with value for the industry where you can create open networks, and I think one of the very important things that you said there was vendor lock-in, and not only from the OLT side, but from all your other infrastructure on your network, because we saw it with COVID, with supply chain management issues. So yeah, it's a great strategy, and I think all those things when you're looking for OLTs or ONTs, because that was a really interesting one as well. I think is spending more money on the ONTs than you do for the OLTs. So yeah, are there any questions that anybody wants to ask? So it was obviously well explained. Yeah, so we're going to, I think we'll just carry on with that. Thank you very much.
Thank you.
Okay, yeah. So we had a bring your own today with laptops and presentations. So just while we change over, so Nardis is going to be speaking next. Nardis is from Nokia, but has put in a huge amount of effort into the ZNOC community. He ran the Container Labs workshop on Monday, really, really interesting one on how to, what do they call it, digital twin your network. So you are able to lab your entire network on your computer. So for those people that don't know about Container Labs, go have a look up on that. And so today, Nardis is going to speak about GNMIC, another acronym, and probably way over my head, so I'll hand over to him right now. Thank you.
Thank you. Good morning, everyone. So, yeah, indeed, my name is Nardis Leroux. I am with Nokia. I'm a consulting systems engineer for all things IP. I like to solve challenges and problems. Today, however, I do not want to talk about Nokia. I actually want to talk about something that should be at the top of everyone's priority, managing a network. And that is using telemetry. So not merely monitoring what's going on in your network, but really having a deep understanding of what's happening in your network. And I really want to call you to move from basic monitoring into actually using telemetry to gain exactly that. So GNMIC, we'll talk about the tool. So what is GNMIC? It's an open source tool. It's free as in beer, so we talked about free things, open things. It is open source as well, so you can go on and play with it, download it, use it, and I'll actually show you how to actually do it. Now, you'll see why get, set, subscribe, and collect is part of that, so let's get on our marks to get going. I think the first thing really is, why do we want to move from pure or basic monitoring to telemetry and to rich understanding of what's happening in your network? Networks are getting more complex, they are getting bigger, okay? And with that, we actually need better understanding of what's happening in our networks, okay? How do we do that? Well, we do that with statistics. So far, the industry has loved or hated SNMP, because that's what we have for a very long time, okay? If you like OIDs, you're on your own, I don't like them. And it's a clunky protocol. As networks scale, it's okay to manage networks for, up to 500. But if you're trying to manage a network with, 5,000, 10,000 network elements, SNMP becomes non-scalable, okay? The other thing is, as networks become more complex, we need more insight into data. As the traffic that networks are carrying becomes more complex, we need additional counters and visibility. If you think about, let's say, take the example of a GPU cluster interconnect in an AI factory, okay? So we need no loss, we want no latency, because all of a sudden job completion times becomes important. You care about ECN messages, you care about ROCKY and RDMA, which isn't the case for WAN networks. Okay, if you think about your internet uplink, do you really care about ECN messages and Rocky and I don't know. It's not there. You care about throughput, maybe you care about latency, and that's about it. Maybe you want to see how much business bytes you. That's it. Okay. So there's a whole new set of information, elements of information that we want to look at to try and understand what is happening in our network. The other thing is we need something more CPU friendly. Okay, so for people that has tried to use SNMP at scale, you would actually know the pain of missed collections because CPU just can't do that because you've got a central location, polling, hey, what's this counter? They respond. 15 minutes later, hey, what's this counter? They would respond. And that just does not work. Okay, so we need something else. The other thing is we need reliable delivery. And yes, I know we've added band-aids to SNMP to try and make it more reliable by introducing session counters and whatnot, but that's a band-aid at the end of the day. It's still UDP. We still hope for the best. We still kick it down, and so we need something that is TCP based. The good news is there's been this marvelous protocol introduced called GNMI. So what is GNMI? It stands for gRPC, Network Management Interface. So what is gRPC? gRPC is something Google initially introduced. So that's our RPC framework. Highly efficient, so to message or move information between a client and server. Okay? And the network management interface then is based on gRPC, but the whole idea is to actually manage your network elements. Okay? How is it made up? Well, GNMI has 4 operations. There's the capability, so you can actually ask, what is your capability? And it would respond. Okay? Don't bother too much with that because it's a fairly simple capability. The other one is get. There's another operation called set and subscribe. And those 3 operation types actually gives us a lot of leverage. Okay? Then, how does it fit into the stack? So GNMI obviously is on top of gRPC, so that's the client server framework. And then, because it's model driven, the data model, the definition of what we're collecting, is based in game files. Okay? How do we transcode or transform that information? We use protocol buffers or protobufs. It's a very efficient way to transcode information and transport that. If we move down the stack, then yes, it's based on HTTP2, so we can get all the benefits of HTTP2, so we can multiplex different messages into a single TCP stream, so that's cool. And well, because it's TCP, we can, of course, then secure it with TLS. So we solve reliability, we solve the security, and this is a modern protocol. It's also a lot more efficient on the wire compared to SNMP. Okay. So, what is GNMI-C then to GNMI? Well, it's a number of things. One is it is a command line interface so that you can interact via GNMI to your network element. Okay. Next thing is it is a highly available collector to collect statistics from your network elements. Okay. And then on top of that, we also have a Go API that is very user friendly from a human perspective to be able to interact with GNMI-C by itself. Okay, so if we then, just before we dive into the details of it, yes, GNMI-C was developed internally within Nokia. At the time, we actually looked at what is happening in the community, and there was really not a lot of options for GNMI collectors and tools. There were a couple, and there still is a couple of, there are a couple of collectors out there, but it didn't really fit into all the things that we wanted to do. And if you're trying to set up a real-time telemetry stack, you need a pipeline. And a lot of those tools actually do not provide the capabilities for that. Okay? So what we then, I think about 3 years ago, Nokia decided to donate GNMIC, the application, the tool, to OpenConfig. Okay? So it's completely open source. It's now part of the OpenConfig project. So you can find it on the openconfig.net project page. And it actually fits there quite well because OpenConfig is doing a lot of good work to try and standardize data models in the industry. Okay? And because it's ultimately game-based, we can actually do the collection of GNMIC. So that was a good fit. Okay. So apologies, we're ahead of.
I realized 5 minutes into it that we started early,
Okay.
and we should have actually held off a little bit.
Sorry. So, if we get into the operations then of GNMIC, the very first one is the get command. Okay, and as you probably would imagine, get then is asking for information from the network element itself. The whole idea is that the target, the network element itself, that you would actually send a GET request from GNMIC to it for a specific path, a leaf, a YAML leaf, okay? And you would ask, give me the information of this configuration store, this path in the configuration store, or the state store, because once you talk about model-driven managed devices, there's typically a configuration store and a state store, okay? And we expect then that the target or the network element would send us the response back. The easy way is, obviously, if we use GNMIC interactively on the terminal, it's as easy as doing a GNMIC, the target name, give it some credentials. Again, if we wanted to do the security, we would obviously have certificates. In a lab, yes, skip verify is easy. We can specify the encoding as well as the format for it. And we then specify that this is a GET operation. And we specify the path that we're interested in. In this example, I'm asking to get the information of the path, which is called the host name. Yeah? And on the right-hand side, that's something, yes, there's a couple of snippets I've taken out to show you only the relevant information, but that's typically what you would get as a response back. There's a timestamp. We would say, well, this is the element, and the value is the host name of that network. So in this example, that's leaf 1, and of course, if you decided to have a different encoding, a different protocol or proto format, then it would look different. But that's a very cool and easy and efficient way to understand what is happening for a state path or a config. So we can actually get config out of the device network. The next one then is the set command. So guess what set does? Well, we can actually now change configuration of the network element. The whole idea then is that we modify the target or the network element configuration, and this allows us to do some create, update, delete operations on the device itself. Very simple again. GNMIC will actually, you would send the set request, and once it's done, it should respond and do that. It's not hard. What does it look like? Again, GNMIC, I specify that this is a set operation. Okay. I specify the path that I want to do something. I want to delete it, I want to update it. In this example, I actually want to change the admin state of Ethernet 1. Okay. That's what we do. That would be sent down to the device, and we would say, yes, Ethernet 1.1, we are going to update the state of it. Okay, the configuration. And that's quite cool. The other thing, once the material becomes available, at the bottom you always see these links. Those are links to the documentation for the specific operation or the specific thing we're talking about. So feel free to head over there and have a look at it. So far, we've talked about fairly mundane stuff. This is what I was talking about, where we actually need to move away from monitoring and get into real network visibility by using streaming telemetry. And the operation that we'll use for GNMI is the subscribe operation. The cool thing is, and it's probably dead simple, probably expected, is we register our intent to the target that we are interested in a specific set of updates for a specific path. Yeah. How do we do that? Well, we actually, from the GNMI-C client or collector, we actually send a subscribe request that gets registered as a telemetry subscription, which is a subscription on the device itself. And instead of the GNMI-C continuously, like SNP days, pull this guy for updates or information, the network element will actually send that out when it's ready, as per your request. So this is cool because now all of a sudden we can get streaming telemetry from the network elements when it's available or when it's ready, based on your subscription request. And this gets more scalable because, well, if nothing happens, well, I don't need to poll you, and you don't need to reply. Okay? And once we've collected it with GNMI-C, we can then do some stuff with that information. And more detail to come on what that stuff is that we can do with the information that we collect. Now, this is the really kicker, or the cool kicker, at least for me, is we have two options. We can actually specify a sample interval. So we can send a subscribe request, okay? Again, specifying the encoding, specifying the path. So in this example, we are interested in interface counters, okay? We want to stream this, and it's a sample stream, and the router should send, or the network element should send every 10 seconds the counters to the collector. And again, depending on your network element or your network operating system of choice, there will be limits as to how quick you can do this. But the whole idea is to actually not collect every 15 minutes, like in SNP days, or every 5 minutes. Even 5 minutes is an eternity if you think about packets moving at 800 gig. Interfaces, it's like the whole world could have collapsed and you still don't know anything about it, okay? Which is not cool. So at this point in time then, this device, if that subscription is registered, every 10 seconds it would send you an update and stream that. And the collector itself didn't need to ask again for anything. It would just receive that in a super optimized way. The other cool thing is we can make a subscription for a GNMI on change. So that means that the router says, well, again, we can define any path that we're interested in. It could be an interface, it could be a routing table, it could be a BGP peer. Again, dependent on what your network operating system allows, okay, because some of them are more flexible than others, okay. But the whole idea then is I would make a subscribe request to a specific path. In this example, I'm interested in the operational status of an interface or interfaces, okay? And it's a streaming subscription, and I only want to hear about the device if there's a change. So if the interface goes from up to down, or if it goes from down to up, or if your BGP neighbor is going from established to open, or to open connect, whatever the case may be. And the cool thing is then, you'll only hear when there's a change. Now again, for the guys saying, well, hang on, how do I know if this thing is still alive, or has it lost the subscription? You can, of course, set heartbeat intervals so that it just pings you and says, well, I'm still alive, and by the way, this is still the status of this interface. So all of those bells and whistles are catered for. Again, have a look at the command fields. Okay. So this actually allows us to do some pretty cool things, because now we can register our intent to receive information from the devices themselves. And again, this could be, dependent on what your network operating system allows, but it could be as simple as bits in, bits out on an interface. It could be memory, it could be CPU, but it could also be funky stuff like queue buffer depth. Okay, to see how congested are your buffers, are your interfaces buffering, and are you expecting latency? It could be latency changes, latency results. Okay. In some of the applications, we actually use latency a lot, so latency measurements, and that gets streamed to the collector so that we can do some stuff. So the outputs then, what do we do once GNMIC has collected that information? We can actually output this to a number of different places. There's a lot of output options. Of course, we can display stuff in the terminal, but that's not useful. At least not if you're trying to do stuff. We can dump that information to a local file. There's an awesome integration to the NATS framework for cloud native applications. We can push that information out into a Kafka message bus so that other devices or other applications can be notified or subscribe to that information and consume that information. We have integration into time series databases, so you can obviously then store the information so that you can do some calculations or some manipulation, or even then do some reporting and stuff from the database itself. These are two interesting use cases. GNMIC also allows us to take that information and send that off to a UDP server or a TCP server or some other things. One of the unexpected use cases we saw how GNMIC was used is someone actually used GNMIC to listen to gRPC information, events, statistics. They then use some of the capability to convert that to SNMP messages and send that to an SNMP type receiver. So if you desperately want to hang on to the past and live there, you can do that even within the gRPC. Not recommended. Good. The other cool thing is, and this is where the Swiss Army knife thing comes in, is GNMIC allows us to do some processing, we call it processors, okay, to do some processing on the information that we've received. Okay? Some of these processors include data manipulation, so we can actually do some type conversion, we can group stuff, we can even enrich messages. So we can add some of the messages that we're not getting from the network element. Let's say it's business logic, and we can add that to the messages and pass it on. Okay, that's quite cool, because now all of a sudden you get some really rich data, and you get only the data that you're interested in. Some of the other capabilities are you can actually obviously do filtering, so you can allow or deny stuff. You can actually strip information out of it and send this on. So really cool stuff. The other thing is, and this excites me to no end, is we have the capability to trigger something based on information. What is this trigger? Well, we can set up another GNMI operation. So if we receive information from a telemetry stream, we can trigger and do a GNMI operation. So think about, I'm getting a telemetry event that a BGP neighbor has gone down. We can trigger a GNMI set to change a policy, a BGP policy, or shut a port, or unshut a port. Think about the cool things that you can do with this. Some of the other things is we can kick off a script, a shell script. And that shell script could obviously do anything. in life. We can make an HTTP operation, or we can even populate a template. Some of the cool things, and this portion, why it excites me, is you've got everything you need to do closed-loop automation. What is closed-loop automation, you may ask? Well, this is listening to events and information from the network. If you receive a specific event or you process a specific predefined threshold, you trigger something. And that something, like we said, could be any of these things, okay? To do something else. It could be to alert from the fire brigade, send an email to the ops team, okay? Or, well, it's the same thing. So for the people in ops, yes, I feel your pain. But you can also then make a change on the router to rectify that thing that just happened. Some of the examples that we actually use with closed loop automation is we subscribe to LLDP information. Okay? Once a new neighbor is established, we obviously get an LLDP update. There's the information. Trigger is, well, we update a template. That template draws your real-time topology of your network. How cool is that? Now you've got a real-time updated network topology based on LLDP. So as ports go up and down and LLDP neighbors are established, you've got a live topology. How awesome is that? One of the other things, and probably closer to a lot of use cases I'm dealing with, is BGP stuff. So if a neighbor goes down, I actually want to change a policy, apply a new BGP policy, update a policy, add some new ACLs, remove ACLs, change QoS policies, subscribe to error rates or DDM information, receive power for your optical plug. If it goes down, before it hits the threshold where the link just goes down, I actually want to reroute traffic away from that link, shut down the link, send an email to the ops team to go and investigate. Because sooner or later that link will just unexpectedly fail. This is pretty awesome, no? Okay, it's just me getting excited because it's the last day and it's a bit of yeah. Some deployment examples then of how we can actually deploy GNMIC. GNMIC supports clustering out of the box, so it will sort out itself. It will designate a master, it will designate worker nodes, so you can actually set up GNMIC as a cluster of connectors. Okay? Like we saw, we can do some processing and some output to various other places. Okay? Again, there's a lot of deployment examples on the open config on the project page itself. There's a picture on the right-hand side. Of course, you will not deploy it like this, but it just shows all the outputs and options for you. But at the heart, GNMIC is actually there in your pipeline, enabling you a real-time telemetry-driven pipeline for what's happening in the network. Okay. So, maybe this is all too high level, so I thought let's show you a small demo. And again, this will not scale to thousands of nodes, but it's really to communicate the concept of what you can do with real-time information and how you can use that to visualize what's happening in your network. It's a very simple lab. By the way, it is available freely to download, spin up in Container Lab. So if you missed the Container Lab, have a look at that. Pretty awesome tool. Fairly simple. It's a leaf spine architecture, 2 spines, 3 leaves, 3 clients. Client 3 and client 2, we will send traffic towards client 1. Okay? We've got an open source telemetry stack, which is comprised of GNMIC, so that would collect all the information from the network elements. That will feed the information to a database, and we will visualize that with a dashboard application called Grafana. Okay? Fairly popular, very often used. So, but with those 3 components, you can actually do stuff. You don't need to spend millions of dollars on this, and it's all open source, so you can actually get going. So the whole idea, like I said, the network elements will send gRPC messages to GNMIC, to the database, to Grafana. So I'll show you the demo then. So we will actually start by starting the traffic. So I'll just do a start the traffic. And then you actually see the dashboard itself. So we have a network topology that we visualize. We use some plugins called flow plugins to actually visualize the flow of the data. These are the statuses of the ports itself, okay? And we also have pictures to show you what the equipment looks like, and we've overlaid the status of the ports, okay? At the top left, we have the throughput. So each of these lines is an interface, and then the traffic has actually started flowing, and we see that the traffic is load balanced across the links, and we actually see, with colors, the throughput of the traffic itself. If we scroll down, we've got some more stuff for leaf 1. Of course, you can select. We see the ECMP routes, the total ECMP routes, active routes, the status of the service itself. We also have a prompt tail Loki pipeline to look at the logs of the device itself. What we want to do is we want to shut down port 3 on spine 2. That means that link will go down. Okay? We will commit that, so disable it, commit it, and what do we expect to do? What to happen? Well, that port will go down, the link will go down, the node or the network element will send a gRPC message to GNMIC. Grafana gets updated every 5 seconds at this point in time, and we will actually see that that port will go down, and traffic will be moved onto the remaining, the uplink. So there the port goes down, we see that the port actually being represented as down. We also see that traffic has moved to the only uplink now. The utilization is shot up because, well, it's not load balancing anymore. If we look, the ECMP routes are only 1, it's not 2 like before, we lost that out. Okay, makes sense. And we also see some BGP info, the log, the updates that we've lost that out, stuff like that has gone away. So this is fairly, this is like 10 seconds later, okay? Which is pretty cool. Now, of course, if we enable that port, we expect obviously the reverse to happen. And hopefully we will commit that. And if we look at it, first thing is that port should come up, the link should be established. Once it's up, then BGP can start to reconverge, learn the routes, advertise them, and do that. So there, the port is already displayed as up, obviously on the device view as well. Then the next thing, of course, BGP needs to reconverge because this is a BGP leaf spine setup. And once the BGP information is coming into the log, we expect that the dashboard should be updated with the route that it learns. The ECMP should be updated, and we expect that the traffic should, once everything is okay, be load shared or load balanced across the link. So once that is updated, we will actually see the dashboard being updated. So then you see ECMP routes active as 2. We see the additional route being learned, and there we go. Yeah, the traffic is actually load balanced across both objects. Okay, so again, yeah, this is some idea. It's not to say this is how you should manage your network, but this gives you a couple of ideas of how you could visualize what's actually happening in your network in a sort of real-time basis. Good. So who's excited to do some stuff? Yes, perfect. So the next question probably is, cool. What do I do next? Where do I actually start? Well, read the fancy documentation, okay, on GNMIC OpenConfig.net. It's really well documented, just like Container Lab. That's the thing I love, there's good documentation. Really easy to read. And if you then say, well, awesome, sign me up, let's do this. We have a lot of deployment examples on the project page itself, packaged as either Container Lab topologies, where you can just spin it up, or if you say, I don't like this Container Lab nonsense, I'm a diehard Compose guy, there's Compose files as well for these labs, and you can actually spin that up. So that's what I wanted to share today. Hopefully I've inspired you to forget about SNP, get into a more modern protocol, and actually start to leverage all the statistics and telemetry that the network operating systems provide. Because from a vendor side, we are obviously making sure that a lot of telemetry and information is available to empower you to actually understand what's going on in the network. So the cool thing is then, well, let's do this and actually know what is going on in the network. So that's what I had. If there's any questions, happy to try and answer them. And if not, well, hopefully I've inspired you to at least look at the application itself. Thank you.
Thanks, Norbert. Don't run away. There must be questions. Right. I'm going to hand the mic around. If you have a question, name and
Hi, Graham from the internet. So I understand that SNMP is old and it's potentially outdated. This is obviously subscribing to specific information, and I find that when you're sitting with 100,000 interfaces in your network, then is this gaining you that much versus SNMP? If you want to obsess over one specific subset of interfaces, certainly this is the right way to handle it. But as the kind of general baseline, what is the background state of the land, I feel like SNMP is still a good tool for that. Do you have a thought either way?
Yes, I actually do. So, streaming telemetry or gRPC streaming telemetry, so it's actually very good. And GNMIC allows you to have sort of scalpel precision on what you want to collect and what is interesting for you. Now, you said 100,000 interfaces. Yes. Have you actually tried to scale that with SNMP? How many collectors do you need to bowl and look at the chattiness of your management lane, or your out-of-band management, or your DCN, whatever you like to call it? It is insane. So gRPC actually is very, very efficient from the amount of data it transmits on the wire. Okay. The other thing is, and yes, you're absolutely correct. I take your point that, oh, but now I need to make all these subscriptions. And that's where a good SDN controller or management platform or whatever you want to call this, if you're still stuck in element management days, then, but that will help you to create those subscriptions in a scalable way. And also then, because the collector is horizontally scalable, so you will actually scale it outward, scale it up, to cater and cope with all the statistics that you're trying to do. So the magic there is not, think about all the subscriptions, it's having a tool that allows you to do that easily. Is that okay? Good. Any other questions?
Hi, I'm Max from Team Company. I've seen a presentation of this at the RIPE meeting from Cloudflare, and was going to try to help you with your previous answer. Like they do it at large scale. They use GNMI. The problem I've seen though, and that you could also see in that presentation, it's the question I asked there, is the lack of tools that there are for those who don't use let's say common hardware, common systems. So for example, I use software routers in my network and previously, and there's nothing to do GNMI over that. So that's the one obstacle that I've seen and I would be nice, I would like to use it, but I don't have the tooling at the moment.
My answer is and might be slightly biased because we have a cool network operating system, but use better network operating systems. More modern ones maybe. Not better, but more modern ones.
Right, I think we finished the session. No.
Hello, my name is Nishal. Unfortunately, I missed the first part of this. And I'm really sorry, but I have to say, as a new user of the Nokia ecosystem, I'm excited. So you've excited me, your hardware, and your presentation to want to do this. In fact, it was one of the reasons I chose you. How do you marry what he was talking about, right? How do you marry the disconnect between some systems doing this very well and other systems not doing that? Because I think that's the thing that people are worried about. People are saying, I can't do this. I may be excited to do this, but I can't do this because I'm worried that my first world, super high-tech infrastructure that I've just purchased can do this fantastically. But I've got to maintain a legacy Linux system, which is a poorer operating system, by the way. I've got to maintain a legacy system that doesn't have access to things. So kind of building up on him. I mean, how do I get a consistent view of everything across the network when I don't have perfect parity between the systems? And what else would you give to other people? Because I've got your creative analytics.
It was never meant to be a Nokia school session.
I'm saying.
Well, thank you. I will say that. I think a mixed vendor or a mixed device type deployment is a fact of life for everyone. We see that everywhere we go. There's hardly ever where it's a total greenfield and everything is just one vendor and there's feature parity. My only question then back to you would be, do you want to actually dumb down your operations and your visibility to the lowest common denominator and be stuck blind? Or do you want this pockets of excellence and at least have the visibility there where you can? And maybe that inspires you to modernize some of these operating systems with stacks that allow you for more. Because again, I guess it comes down to the application as well. So when we sort of started talking about this, we talked about how applications on networks are evolving. It gets more complex. So if you think about a GPU cluster interconnect on the back end within an AI factory, you care about other counters than people in the WAN or your internet uplink. And it's absolutely critical for the maintenance and the operation of that network to do that. So, it would be heresy if you go and convince someone in an AI factory data center that the GPU interconnect you should collect once every 15 minutes via SMP because that's the common denominator. I think that just doesn't make sense. So, not the perfect answer. I totally appreciate that. But I would say let's strive for excellence where we can, and where we can't, okay, either suck it up or rejuvenate to some more modern systems.
All right. Thanks very much, Niles. I think there are more questions. I actually had some questions, but we're out of time. But I think what this is showing us is that I think everybody that's just come in, welcome. Come find a seat over here while Max sets up, because it's the bring your own laptop session today. So I think with this, I've makes my brain really tick when a technology like this comes along and what is possible. But it is still relatively new when you're comparing it to SNMP, and even some people are not even using any sort of monitoring on their network. So, but yes, I think it's really exciting stuff. So moving on, Max is from Sweden, and Switzerland.
Same place.
Switzerland, and he's got a slide on who he is, so I'm not going to introduce him.
Please.
You know, I've received packages from different places sent to me in either Switzerland, Sweden, or Swaziland. And but they still make it to Switzerland. So, good morning, everyone. I'm Max. My name is actually a bit longer, but Max is better. I should turn this on. And I used to work at RAG-NCC. I worked at Internet Society. So I've had different views of the internet there. Now I work at Team Cambri. I also help URIX, and I run a small company. I collaborate with a bunch of IXPs, a bunch of program committees. I'm on the board of SWINOG. We're having our annual meeting next week. I'm a FreeBSD user, which now I learned is considered a minor operating system. And I run a small autonomous system, which also helps me try out these things. And, yeah, you can see a picture of me when I still had way more hair than I do now. So, before we start digging into what ASPA is, I'm taking a couple of steps back and giving you an overview of what RPKI is, so that we're all aligned. It will take a few minutes. So when we try doing routing on the internet, we have BGP, and we have two networks that want to talk to each other. And what they do is they send an announcement. So they say, I have this network, please put it into your routing table so you know that if you want to send packets to that destination, you can send them through me. And the other networks do the same. So you build two different routing tables, you build knowledge about where to send your packets. But the problem is, let's see, do you have any idea of when BGP was designed? Like, which years? Like the last version we have is BGP 4. Before I started also in the industry, I was in elementary school to make somebody feel old.
Well, it would be before CIDR, so it has to be before 93. So
Yeah. Well, no,
it has to be before CIDR.
BGP 4, no. BGP 4 is 94.
So the concept of how
The concept was early, but my point is, this came when the idea was, let's make things work, and we'll think about security later, or there's no concept at the time. So there's nothing embedded in BGP that helps us determine, like, a question, like, can I trust that what I received from the other network? Can I check the correctness of what they sent me? So there's nothing embedded into BGP. So we need an external database, and we have the Internet Routing Registries. And I say plural because there are so many. So we can ask the routing registry, can you check if this data is valid for you? And we do this via objects in the databases that are called root objects, route root objects. They tell us this autonomous system is allowed to be originating, so to be announcing this network. So we take that data and use it to filter what we receive from our peers into the routers. But this is suboptimal because there is data in many IRRs that you cannot trust. There are a couple of them where you just pay a fee, you get your maintainer, which is basically your password, your authentication system, and then if there is no object covering that address space, you can create your own. And there's no check on if you are the holder of that address space. So this is very prone to hijacks, is very prone to issues. There is incomplete data all over. I was writing a software at one point to do some checks on route objects and compare them with other data we had. And I realized that there's a whole country, a whole tiny country, where there is no single route object that sits in the appropriate database. And that is a big problem. There are more than 30 IRRs. So when you want to figure out where to get your data, that's a problem. So in 2008, the people started, the RPKI came to life and started using it. The idea there is that everything follows the registry hierarchy. So we have 5 entry points, and that's it. We're not supposed to be having any other databases, any other places to get the data. And the idea is that we add a little bit of cryptography, a little bit of crypto to figure out if the data we're seeing in the database is right. So we can use it to follow a chain of trust to figure out, is this what is supposed to be in the database? So we have two major changes now. We have safety. We know that there are only 5 databases, the 5 regional registries, and then we have one thing that is, I can validate the data that I get from this part. So we add a lot on top of what we have. And what we do is, we have the IP addresses, we have the public keys, we follow the hierarchy of the registries, and the initial purpose of RPKI, which was just one, was get a statement from the holders of the address space that says, I am the holder of this network, and I'm allowing this autonomous system to announce that. Very, very simple. But there's signature, there's something I can validate and start from there. So it works with 5 different repositories, every other registry, and then there can be delegated repositories. I'll get into this in a moment. But the idea is that I have 5 repositories, I have data, I can download it, I have a software that's called a validator or a relying party. The validator does all the crypto magic for me. I'm not going to go into any details about that today. And then it gives me data that my routers can use directly. So there's a dedicated protocol for that. It's called RPKI RTR. And once I get all my data into the validator, I've done ROA validation. So I validated that everything is fine in my chain of trust. Like the certificates are all valid, everything's fine. I paid my dues to my RIR. And then once I get the data into my validator and it gets to my routers, it helps me make routing decisions. So I do origin validation. I verify that what people have put into RPKI corresponds to what we find in BGP. If the 2 data match, then I can accept the BGP announcement. If they don't match, I will leave it out. So far, so good? Yes. Because Aroa, so we have objects, sorry, twice. We have a main object in RPKI, that's what people have dealt with so far. That's Aroa. Aroa is a file, a simple file that contains 3 pieces of information. It contains a prefix, contains an origin ASN, so who's supposed to announce it. And then when they were designing RPKI, somebody decided to honor me and call it a part max length. So they used my name for that. But basically the idea is that I can tell it, I can say, I have my prefixes as /16, but I'm allowing this ASN to originate anything up to /24. It can be useful, it can backfire. And that's a long explanation that's needed. But if you have such a large address space and and you're thinking about using max length, I will urge you to read about that. There are suggestions on how not to do that. So, where do we go from here? We have building blocks. ROAs are the first step through path validation. The problem is we are only looking at who is originating the address space, but we're not looking at anything in the middle with ROAs. So we need something. We need something additional. And there were ROAs, and at one point came BGPsec. Has anybody ever heard of BGPsec? Yeah, okay. 2 people, 3 people. You know, do you have any idea why you have not heard about BGPsec? Because it's heavy. Because it is the optimal way, it would be the optimal way to do path validation, but it's heavy. Because what happens is, give me a second, I'll show you here. Basically, in BGPsec, my router receives a BGP announcement, and the BGP announcement contains an AS path. And the BGP update contains a BGPsec field that contains a signature and a pointer to the key that signed that. So for every ASN in the AS path, I need to go fetch the key, do a validation of the whole chain of trust, verify that everything's fine, download all the intermediate certificates and everything, and then if all my validation is good, then I accept the BGP update, put everything in my route, and then I sign the path again, add my key, add my signature, and then send the BGP updates to my peers. Do you know the average length of an AS path on the internet these days? It's about 7. And if I have 7 ASNs in the AS path, and how many routes do I have in the full routing table these days? About 1 million.
Sorry,
Yes.
this feels like overkill. Do we really need to sign the whole path, or can't we just sign the?
You sign the whole path, and then you validate the whole path. So the question was, if this sounds overkill, do we have to sign the whole path or not? Yes, you sign the whole path.
Can't we just sign where it transits? In other words, AS1 does the export of AS2, so we just validate that.
Yeah, you just validate. Well, you validate every single. So you validate every single. Let's say, net2 would remove itself. Well, take net1, take net0, net -1, and it would do all the validations of that. So that's where I was getting. If you have 1 million routes in the full routing table, you have an average AS path length of 7, you need to do like 7 million validations of the chain of trust first, which involves downloading different certificates, different keys and everything. So it's a lot of computational capacity that we would be using to do that. Routers these days cannot do that. And there is no path that we're aware for any vendor that said, we're going to implement it in the next version of our hardware or whatever. You need dedicated ASICs for this. So this doesn't work. Unfortunately, this would be perfect, but we don't have it. It's just, it requires too many resources. We don't have routers that can do that. There was a study that Joop Snijders did to show that we could actually do this at internet exchanges on the route servers. And the route servers could be, like Bert could have an implementation of BGP-SEC. It requires a bit of money to implement that, and he's still looking for that money. But so far, there is nothing. No BGP-SEC. There's a partial implementation from NIST, from the US standard system, but nothing that we could use these days. So, for now, we can call it the future, because we can't implement it these days. So let's look at the next idea for doing this. Instead of validating paths by signing, we validate paths by declaring upstreams. So we do it in a lightweight way. And this is the present of RPKI path validation. So, ASPA is an object, an additional object that you can find in RPKI. You basically list the upstreams of an ASN. It's still in draft, so we're in the final stages of getting it through to be an RFC. Actually, it's 2 RFCs, one that defines the object itself and one that defines how you validate it. And basically, what I like to do is tell you this is what an ASPA is. ASPA contains a list of your upstreams, and those are, well, except for one that I put it as a little Easter egg for the gentleman sitting in front here. You basically just have to create an object that says, these are my upstreams, that's it, done. And I could stop my talk here, because this is all you need to know about ASPA. That's really simple. What you need to know is go in when Afrenik will enable that, will implement that. When? I'm saying when. I'm more positive. Yeah. But what you would need to do is go in and literally for RIPE-NCC members it takes 30 seconds. You list all the ASNs that are your upstreams. And what do you do with this? Basically, whoops, sorry. So I have a sort of a defective. So it's distributed as part of RPKI, so same as in ROAS. It's signed, it's supported in RPKI FTR2 version 2, and also this, it's a draft. They decided not to create a new RFC, but they decided to update the latest version of the draft. So it's RFC 8210 bis, which adds the ASPA objects. It's available at RapidCC hosted RPKI, Aaron hosted RPKI, and the APNIC hosted RPKI from end of Q2 2026, so it should be coming soon. And you can use it in Krill as delegated RPKI. And I know that the additional problem is Afrinic is not listed here, but also Afrinic doesn't allow you to do delegated RPKI, right?
Sorry, could you say that loudly?
Shall I say it more? Yes, so let me put the microphone better. So you can't do, it's not implemented as in a hosted version, but also you cannot do delegated RPKI in the region, right?
That is good.
Okay. So at one point you will be able to do this. And every ASN should have one, just one. Theoretically you could have more than one, but if you have conflicting information, it can be a problem. So how does it work? With ASPA, imagine everyone creates their own ASPA, so every network has one. What we end up with is a way I can download all the ASPAs I can see, and with those I can create a graph of who is upstream of whoever else. So I can actually build a whole graph of how the internet is supposedly connected, as declared by every single autonomous system I have. And with that, I can validate when I receive a BGP update, I can look into the AS path, and I can take that, look into my ASPA graph, and see, does what I see in the AS path that I received from my neighbor match what I see in ASPA? And that's a little bit more complicated than it sounds. I started looking at it and thought it would be relatively simple to implement, but it's actually a little bit more complicated. And let me tell you how I discovered that, because Bert, Bert the routing demon, actually got the implementation wrong at first. And if they got it wrong, then I'm not going to get it right. I know that. So I have my three networks here, A, B, and C, and with their ASPAs, they're declaring different types of networks, different networks as their upstreams. I have ASB, I have ASC, and then C announces AS0. AS0 tells me I don't have any upstream. I'm supposedly a tier 1, or I don't need to have an upstream because I don't want to have one. On the other side, I will have other networks that declare similar things. Oops, now you'll get the animation again. But what I end up with is a situation where I have what's called in ASPA on the left. Hold on a second, because there would be up and down ramps. No, disappear. So I have an up ramp on the left and a down ramp on the right. And in the middle, I have ASC, that is the top for everyone. So with this in mind, I have three states where my ASPA can be. I have a state that says provider, so the ASPA exists and defines this ASN as an upstream. So if I look at my ASN, it declares that there's another ASN as an upstream in the ASPA, and it is there, then it's a provider. I have a state that's called not provider when the ASPA exists, but if I look into that, this ASN is not listed as an upstream for that other ASN. And that gives me a not provider state. And then I have no attestation where I don't have an ASPA, so I don't have any data to validate my AS path with. And these carry different signs. So when I verify, if I don't find any situation that says not provider, everything's good. Because the idea was to, at least at the beginning, fail open. Like many people will not be able to, or will not want to, create an ASPA right off the bat. So the idea was to fail open, label situations where you have no attestations. So as long as you don't have a situation with no provider, that says something is wrong between ASPA and reality, then everything's fine. At this point in time, you can use BERT, OpenVGPD, to do the validation, and Cisco ISXR is being tested actually by people that's not far from where me and Pim are, and it's a switch in Switzerland using a version directly from Cisco to test ASPA. And then Routinator, an RPKI client, includes support for ASPA objects. So not all the software. So I pointed to AS0 and Bogo makes sense because you can use that to say this ASN has no upstreams, and it can be three cases. One can be basically a tier 1 or someone who doesn't need to have an upstream, but also IXP route servers and route collectors. So those are the three cases where you would see that. And I did a check this morning, and there are about 29 ASPA now in the database which have an AS0 as origin, as upstream. So it's being used. So verification works. I can figure out if there's anything wrong in my AS path. So if I have a situation where ASA appears on this side and it has an ASPA that says ASB should be its upstream, but it's sending data to D, and I catch it from this other side of the network, then I will know that there's something wrong, and someone's trying to do something wrong with ASA. I can see the same when here E puts itself in the middle between D and C. So in this case, E shouldn't be there because D doesn't declare it as an upstream. So this would be going directly to C. So if I see a path that goes D, E, C, I know that something is wrong and I can block it. Because again, someone might be trying to impersonate someone in the middle, E, and there might be a hijack attempt going on. Is this clear? Yeah? Okay. Then we can have IXPs in the middle, and instead of going up to C, which both E and B declare as an upstream, we just go directly between E and B. This is a case I wanted to showcase because basically this is perfectly fine. This is just a case where ASPA will see, okay, we went directly between E and B, but they're not upstreams between each other because they're just exchanging traffic here. And then this path would be perfectly valid in any case. Oops. This path would be perfectly valid. The next case is when you have validates. So imagine you have E here that's instead of sending traffic to B, which would be a same level in the hierarchy, has traffic going to C, has a path going to C, which basically is not filtering correctly. In this case, imagine there was a case some years ago where two large ISPs decided to de-peer from each other, but there was a tiny ISP in the middle that didn't have filters going on, and so it started becoming the transit between these global networks. And this would be a case that could be avoided with ASPA, because then that becomes immediately visible that C shouldn't be using B as an upstream because B has AS0. And even C has a different definition in ASPA there. This is a bit more complicated to understand, but these are cases that usually happen when you have people who don't update their filters or don't keep track of their filters correctly. So far, so good? See a lot of silence.
We have to.
Sorry?
We have finished.
Question, go ahead.
I think finish first then, because
Okay.
you provide answers later.
Okay, I don't think they're, so this is basically it because these are the three major cases you can find with ASPA. So I'm doing a wrapping up. You have different objects, and there's one I haven't mentioned because I wanted to give a full overview. There's RPKI signed checklists. In the last couple of days, I heard people talking about LOAs, and there have been cases where we're discussing where people produced fraudulent letters of attestation with RPKI signed checklists you could sign data to be authenticated. So you could sign a file that says I'm the holder of that address space, and you could connect the signature to the fact that you have ROAS in the same under the same certificate. So you're supposed to be the holder of that address space. So then you should be allowed to announce that. You can sign any kind of file. You can sign any kind of. You can put different signatures in there. So it's a flexible system to use to verify that someone is a legitimate holder or someone is legitimately supposed to do something. But this is the update on all the objects you can find these days in RPKI. And so what is ASPA? ASPA in the end is just a new building block to make routing more secure. It still needs to be finally adopted. So how do you start? My suggestion would be, if available, to start by creating ROAs and ASPAs. In other regions, it really takes 30 seconds. I've seen there are now, this morning there were 1,700 ASPAs that people have already created. But you can start also by evaluating relying parties, like the software you want to run to download all this data and look into it. There's Routinator, there is Fort, there is RPKI client, depending on which one you prefer to use, or my suggestion would be to use two of them, different. In my network I use Routinator and Fort. RPKI client is pretty tied to OpenBGPG and OpenBSD, so it's a bit harder to use on other systems. And my suggestion would be to start by logging and not filtering based on the two, and check your customers, make sure they're good with that. There is an ASPA path viewer. There is a software you can check online. It's produced by Andre, who works at Tribe NCC, and basically you can input an AS path, and it will tell you based on the ASPAs it sees if that path is valid or not. And it's a good idea to start checking it and playing with inserting different potential hijacks in the path and seeing how those affect the validation of the ASPAs. And then there is BGP Alerter. There's BGP Alerter, which is a software that I would suggest you use independently if you're using ROAS or not, if you have ROAS or ASPAs. It's a software that checks your BGP announcements and sees if there's anything different from how it was previously. It's basically it keeps a state, keeps an ID, and then it messages you, it sends you alerts if anything in BGP related to your prefixes changes. A longer AS path, different announcements, something like that. You get a notification. So it's very useful to understand if there's anything happening related to your prefixes. And there's also a commercial monitoring service that's run on that, and run by the same people who do the open source software. You set it up in 5-10 minutes. It's really quick. And then I'm done. So if you have questions,
Please go back to your.
Hang on. We are it is tea time, but we will go for 5 minutes.
Do you want to go first?
Jaco, the outbound guy, could you please go back to your slide with the internet exchange? That one, yes, yeah. I think you're missing, let's just get the animation. Okay. So in that case, let's say I am A, and I want to verify the path from D to E to B to A. Okay, it's easy enough to verify that E is an upstream for D, and obviously B is my upstream. But I've got to verify that BE transit there.
it's actually, you don't have a way to do that because that's not an upstream. And then basically what happens in this case is that instead of having an up ramp that goes all the way to C, it limits itself here. And then it just goes down, and then you have the down ramp on the other side. So you don't have a way to verify that this actually exists, but there's nothing in the system that tells you that it shouldn't be there. Because B is not using E as an upstream, it's the other end of the of the communication, where the down ramp starts.
Okay, so in the case where my immediate upstream is compromised, it still becomes possible for someone to hijack routes by injecting a path similar to that for, say, Google into their routing table, which I will then happily accept as long as they've got the right kind of path that everything else around it doesn't violate anything. Yes, I'm thinking worst case here.
Yeah, I get that. It's I would have to think about that. So maybe we can discuss it.
Happy to do that.
Yeah.
Hello, Mama Lisa from the internet. So comforting to say these days. I just want to know the ASPA data. Is it sent in the same payload as your normal RPKI data over the RTR protocol?
Yeah.
The reason why I asked that is, so if I was to deploy the native routinator and I have an old router, will it understand that payload?
That depends on the vendor. I know there are problems with Huawei, where if you enable ASPA on Routinator, by default Routinator doesn't have ASPA enabled, so it doesn't provide them. But if you enable them and you have a Huawei router, then it will crash the RTR sessions. So I would pay attention to that before implementing it. I have BERT does it perfectly. OpenBGPD does it, runs it perfectly, but for other vendors, I wouldn't recommend enabling that. And so ASPA gets distributed. It's not in the same exact payload. It's a different set of objects, different set of files, but then you see them in RTR, and they are different PDU. It's just a different message type.
It's not wise to test routinator now.
I would run my routinator in a lab before doing it in production in that sense. Yes.
Hello, I'm still Michelle. I have one question for you and two questions. The first is, could you go to the slide that was talking about tooling? Yeah, because I think maybe it isn't clear, but a lot of the reason I think that people ignore technologies like DNSSEC and RPKI is because as an industry we really don't have cool tooling. And the problem with technologies like DNSSEC and RPKI is if we do the wrong thing, we end up shooting ourselves in the foot, and people are worried and nervous. So I'm always interested in learning about cool tools that will help me, will show me if I'm doing the thing. So, sorry, that's not the slide I was talking about. Yeah, could you add a sentence or two more on that for folks that may not be familiar how this would work, and specifically how it would help prevent them shooting themselves in the.
Yeah. So creating ASPA is very simple, and it takes 30 seconds. You just the way I would do it is actually I did have a slide where I was suggesting to put this into your checklist for when you add the transit, when you remove a transit. If you were to add the transit but not update your ASPA, then you would have an issue. And that's the major change I would apply. Then tooling, we have the path viewer. There is a Docker image from Epinik, I think, where it does some ASPA validation as well. But I haven't tried that. I have tried this because this is very lightweight. And here you just have just input as a string the list of ASNs. You would see an AS path, and then it tells you if it's a valid AS path or not. And for now, these are the only tools that we have.
My second question is, because I got told that I do lightning talks on the microphone. Do you mind if I hijack you?
Go ahead.
So I'm going to walk to the front.
Because I know there was a reason behind me giving this. That's the second reason behind me giving this talk.
Hello everyone, my name is Nishal. I work for you, and I get sometimes paid by PCH and other people. How many of you think ASPA's cool? How many of you are network operators and you're just not here for the free lunch? By the way, if you're a vegetarian, the lunch is shit. I'm a vegetarian, so trust me. How many of you network operators think Asp is cool and it's something you would like to deploy? So quick show of hands. That's like what, 90% of the room? Max, I hope you count faster than me, your eyesight's better. Okay, and Max explained why you can't do this today, right? He explained why, if you are not like one of the lucky few, and I don't mean that they live in Switzerland that makes them lucky, I mean that because they have access to the NCC's cool portal that they can do it. How many of you have complained to Afrinic that you can't do this? Anyone else? So you want the tool, but you think it's going to happen by itself. Is that your strategy?
Sure. Well, up to now, many of us has not been aware of exactly what Aspect is. You would have noticed, and I have complained previously publicly, that RPKI ROAs doesn't solve the problem.
I don't buy your excuse. No, don't give him mine. Don't give him mine. I don't buy your excuse. You know why? I'll tell you why I don't buy his excuse. Because some time ago, there's this horrible chat thing called Telegram that the Zaman people live out on. Hang on, I know some of you are laughing. And you were talking about, I asked on this thing, because this is how I communicate with you, saying, how many of you think that this is something that you want to do? I guess how many of you responded? A number between, an integer between -1 and 1. But here's the thing, right? Hope is not a viable strategy, unless, hope is really attractive. Hope is not a viable strategy. Wait. Hoping that Afrinic is going to fix, and I did the math. Anybody want to guess when Afrinic's RPKI system went live? Full disclosure, I worked at Afrinic. I was the CTO at the time, so I can speak with some authority on this. 2011, and that would have been
15 years.
15 years ago. So in 15 years, they haven't managed to create this thing called a delegated RPKI repository, even though it's been on their roadmap for a long time. So do you still think that hoping that Afrinic is going to do this, saying, inshallah, it will happen, is a viable strategy? How many of you think that's a viable strategy? Because if you are, man, do I have a castle to sell you in the desert.
So we should send you back to Afrinic.
I still have scars from that experience.
I have to say, there is an additional excuse. The ASP is still not fully defined.
Oh, and RPKI was not fully defined at the point. And Max, since you want to talk about full definitions, when did the RFC for BGP4 eventually get published? The RFC?
You checked.
No, I didn't check.
It was 93.
I mean, I'm old enough to remember.
93, 94.
No, the RFC. When did the RFC get published? So saying that there is no definition, which is the excuse that Afrinic has been using for all of this time, is complete and utter bullshit. Is this being streamed? Because I want to say the word bullshit into YouTube. See if they filter it. It's absolute bullshit, because you can't say, especially as an RIR, that we're waiting for a standard before the thing is available to you to use, even if it is available to use a test, right? And if you feel strongly about the fact that Afrinic should do this, then please join me in a petition. No, I'm not. But join me in writing to Afrinic to say, guys, this is something we want. This is something that matters to us because it affects our operational security. And Max, I think he did a really good job of explaining how it does affect your operational security. Why this is something you do want, and why, up until you get this, honestly, RPKI is just cute. Honestly, there's no better word for it. It is just cute. And don't believe me, ask the guys that are doing this at scale. They'll tell you the same thing. So we can't sit by and idly say, we're hoping that they're going to do this. You need to get up, you need to stand up, and you need to say, this is something that I want. And you need to do it in a structured manner, and you need to do this to the Afrinic team. For the Afrinic folks sitting here, I'm not picking on you. This is something that we need as your members. This is something we want. Well, it's something I want. It's something the loudmouth guy wants, even though he may not be that loudmouthed about it. It's something the guy next to him wants because we've beaten him into submission. And now that you know what ASPA is, hopefully it's something you want because you know why it makes your network safer. But waiting and praying, I'm sorry, that's not a strategy, right? And Afrinic is not going to act unless you stand up and say, this is something we want. So if this is something that matters to you, and it should matter to you, please write to Afrinic. If you don't know how to write to Afrinic, you can find me sitting somewhere in the corridors, somewhere, and I can tell you whom to address and how to get that process in place. Okay, how do you do that?
I'm actually done, and if there are any other questions, otherwise I would ask if you don't see your native language in here, please approach me. I like to add everyone's language. Thank you very much, Matt. Just one, a fairly new site that I came across, bgproots.io. When you do a prefix search, it actually has a column with the ASPA state of that AS path. So bgproots.io, and then also send them a BGP feed, BMP as well. All right, we're way over time. T now 11:30. We're having a very similar presentation to this in the plenary. And then, yeah, so make sure that you get a quick cup of coffee, tea, I'll see you across there. Thank you.